Hi, my name is CJ Chum, and today I will be showing you our kinematics using this soccer ball right here. With every kick, two-dimensional kinematics are being shown. Two-dimensional means that the particle is only traveling in two axes, meaning that the ball is moving both in the up and down direction and also in the left and right direction. The relationship of the position, velocity, time, and acceleration of the ball can be represented by using these formulas. V naught is the initial velocity or the velocity when the time just starts. V is the final velocity. A is the acceleration. X is the position. Triangle X is the change in position. And T is the time. We can use these formulas to solve for a missing variable when there is only one dimension or axis. When there are two, the two axes will have to be separated into the X component and the Y component. This is the ball moving in the X component, which is the left and right direction. This is the ball moving in the Y component, which is the up and down direction.
Is this appropriate?
Together, they make the ball move like this. It's important to know that the X and Y components also share the same time, which can be useful for when solving or relating the two components. Now that you understand the basics of 2D motion, let's break down the different variables in the kinematic formulas.
So here, the ball will be launched by my feet at an angle. The velocity of the ball when I hit it will be the initial velocity. This initial velocity can be broken down to the velocity in the X direction and the Y direction as shown here. Now that the ball is launched, let's break down the other variables of kinematic formulas. Let's pause at right here. So the height is the distance from the ball on the ground. The horizontal distance is the distance that the ball moves horizontally from its original horizontal position. The velocity is the speed and direction of the ball. The acceleration is the change in its velocity. For the y-axis, the acceleration is gravity. And the time is the amount of time that has passed since the beginning of the launch. The x-axis acceleration will be discussed shortly. And as you might have noticed, here's the peak of the launch, which is where the height is at its highest. And since there is no change in overall height, the ball here at its peak has reached 1/2 its total time it will take to reach the ground. Also, don't forget, we are assuming that there is no air resistance, so this means there is no acceleration in the x component. In simpler terms, the speed or velocity of the ball in the horizontal or x direction is not changing. With the ball initially being moved at an angle, we can see how the acceleration of gravity makes the ball slowly curve down while the velocity in the x-axis remains constant. This is a very common example of 2D motion that is not only seen in a soccer field. Here's one last example of 2D motion. With every kick of the ball here, I'm launching the ball at an initial velocity in both the x and y direction. And, unlike in the previous example, the initial height is not at 0 meters. As you can see, it's above ground, so it's more than 0.
Oh, I can see you there. Well, folks, that's the nature of 2D motion. You can find physics everywhere you go, whether it's kicking a soccer ball or throwing a coin. I'm glad you were able to learn about physics in your life. That's our show for today, and I'll see you later.
This will be his last chance for the equalizer. Goes for the shot. No!